everyone, welcome to Augmentic Technology Private Limited. Today I am excited to introduce our one of the product, that is 8DIAIM-NTC. It's an 8-channel digital input, 8-channel analog input and 8-channel NTC for the temperature, which is communicating with the Modbus. Here we have the base model. In this base model we have the power supply connection here. Okay, for the power supply we have provided the configuration as the positive and the negative. You can connect in any direction. Here we use the bridge rectifier which supports the reverse connection for the board also. For this power supply you can provide up to 24 volt DC. And here we have the RS485 for the communication purpose. Here we have the configuration as A for the positive, B for the negative, where we can connect with the RS485 cable to the PC to get the data. And here we have the dip switch part. In this dip switch part, where user can set their own slave ID and the baud rates. For the slave ID, user can set up to 15 slave IDs. And here we have the reset button. Okay, here we have the reset button, which is used for whenever the user need to change the slave ID and the baud rate. To configure with the new baud rate and the slave IDs, just press the reset button. The board will get configured with the new addresses. Here we have the 8DI channel part, which is operated through the optocouplers, which supports up to 80 volt. For this DI, we have given the voltage reference here. Okay, here we have the voltage reference, and for this indication, here we have the LEDs. And here we have the 8AI part and NTC part. These are the 8 channels for the AI and NTC. Here there is a provision for the positive and the negative, which is mentioned in the board. Whenever you need to set for the AI, on that time we need to set all jumpers in a AI condition. Here in the board, just need to shift the all jumpers with the AI condition. Whenever you need to set for the NTC, on that time shift the jumper with the NTC part. For the next step, we will focus on the testing process. Please concentrate on the testing procedure and ignore the board visuals which is provided in the video. In this video, we will only know about how to connect the power supply and how to connect the RS485 with the Modbus cable. Okay, here we have the power supply part. There we have mentioned in the board, that is positive and negative. Connect the power supply with the positive and the negative and provide the power supply. See, here the LED turn on, that means power supply has provided properly. Then get to know how to connect the RS485 cable. Here we have provided the configuration as the B, that is for negative. Here I have connected the negative. A for the positive, I have connected the positive wire. So then connect this wire with the PC. Okay, this is the RS485 cable. So I am connecting this with the PC. Now we will connect the RS485 cable with the PC. So I have connected with the PC. Now open the device manager. In the device manager, go to the port here, that is showing as the COM6. That means I am using the port number 6 for the serial communication. So then go to the Modbus pole, click on connection, connect the board and select the port and click on OK. See, the board has connected properly. After proper connections, here you will get the RX and TX LED blinking continuously. That means RS485 communicating with the PC properly. In this video part, we will get to know how to configure the slave IDs and the baud rates. So here we have the slave ID and the baud rates. So by default, that is the 9600 baud rate and the slave ID will be a 1. So now we will go with the PC. See, here the board has connected properly with the default baud rate and the slave IDs. So now I need to change the slave ID as the 3. Okay, before changing the slave IDs, here this is the dip switch for the slave ID. So here in the dip switch they have mentioned 1, 2, 3, 4. That means the slave ID configuration as a 1, 2, 4, 8. That means if I need the slave ID 3, then I need to hide first and the second pin. That means 1 plus 2, that will be a 3 slave IDs. Okay, then I need the baud rate as a 19200. So the first pin that is mentioned in the board, that is 19200. So I will hide this pin. Now I need to press the reset. So the board will get for the new configuration. See, here I will get the timeout error. Whenever you will get the timeout error, disconnect the board and connect the board with the new configuration. The baud rate as 19200 and the slave ID will be a 3. Okay, see, after connecting this, here the TX has continuous increasing. That means the board has connected with the new slave ID and the baud rate. So now I need to set the slave ID as the 5 and the baud rate will be a 38400. So now I will hide the first pin slave ID and the third pin slave ID. That means 4 plus 1, that will be a 5. Now I will need to set the baud rate, that is 38400. That is the second pin. So I will hide this pin and now I will press the reset. See, here I will get the timeout error. Do the same thing, disconnect the board and connect the board with the new configuration. The baud rate will be a 38400. Okay, then the slave ID will be a 5. See, here the board has connected properly with the new configurations as a slave ID 5 and the baud rate 38400. So now I need to set the baud rate as the 57600 and the slave ID will be a 15. So if I need the slave ID as the 15, then I need to hide the all slave ID pins. That will be a 15. Okay, now I need to set the baud rate, that is for the 57600. Okay, now I need to press the reset button. Here I will get the timeout error. Then disconnect the board and connect the board with the new baud rate and the slave ID. Here the baud rate 57600 and the slave ID will be a 15. See, the board has connected properly with the new slave ID and the baud rate. Now I need to set the slave ID as the same and the new baud rate, that is 15200. See, okay, 115200, that is the new baud rate. Just press the reset, disconnect the board and connect the board with the new baud rate, that is 115200. Click OK. See, the board has connected properly because I have put the slave ID 15 as same and the only change, that is baud rate. Now I need to get back all these with the default. So load the all pins. Okay, otherwise you can set only first pin as a high for the slave ID, otherwise you can low, there is no issue. Now press the reset. The board has gone for the default slave ID and the baud rate. So now here I will get the timeout error. Disconnect the board and connect the board with the default address. Baud rate is a 9600 and the slave ID will be a 1. See, the board is communicating with the properly for the default addresses. This video is for the DI part. So for the DI, we need a reference of the 12 voltage. So here I have connected with the 12 voltage for the male to male jumper. So now go with the Modbus. So here connect the Modbus with the port number and once verify the function code. For the DI, we need to set function code for the 2. Click on OK. See, the board is communicating properly. Okay, whenever the board is communicating properly, on that time here you will get the RX and TX LED blinking continuously. So now I need to check with the DI parts. For the DI, please refer the datasheets for the mentioned registers. From where to where the DI register has mentioned, they are already mentioned in the datasheets. So now I will check with the each DI where it's working or not. So first I will do short with the DI1. Whenever I short with the DI1, see the LED of the DI1 will turn on, and also I will get the value high, that is 1 in the mentioned register. Same with the DI2. So here I will get the LED high, and in Modbus also in mentioned register I will get the value as a 1. Checking with the DI3. In Modbus also I am getting the value as a 1 for the mentioned register. Here also I get the LED turn on for the DI4 also, and I do with the DI5 also, and DI6 and DI7 and DI8. And don't short with the ground. Sometimes if you short with the grounds, the board will get damaged. So only check with the reference for the all DIs. In this part, we will get to know how to configure the 8DIAIM-NTC. Here the board has connected properly with the Modbus. So to check the AI part, we need a one male-to-male jumper. Here we have the male-to-male jumper. In this board we have the configuration, that is a AI and NTC. By default it is a AI. If we need the NTC, just we need to shift the jumper with the NTC part. And also here we have the reference voltage, that is a 5 volt and a 10 volt. Just by shifting the jumper, it will be configured with the different voltage. And also for the AI NTC. By default it's a AI. So now I need a one male-to-male jumper. To check this, we need a one reference voltage, that is a 5 volt. In this board we have mentioned the 5 volt reference. Just take the one 5 volt reference and short with the AI positive. Don't short with the AI negative. Here we have the AI part. Once I short with the AI1, so in the mentioned register at the Modbus, you will get the resolution as the 1023. If I just shift the jumper with the 10 volt, and in Modbus I will get the 512 as a half resolution. So by default it's a 10 volt. So I am getting the 1023 as a full resolution for the 10 bit. And do with the same for the AI2. There also I am getting the AI2 value in the mentioned register, that is 2. Same for the AI3, AI4, AI5, and AI6, AI7 and AI8. These all indicates all the AI part is working properly. Now we will check the NTC part. So now I have shifted the all jumper to the NTC part. So in AI, please ignore the AI values. It's showing the by default as a resolution high. I'll ignore these values up to 8. And for the NTC we will get the after 8 channel. The starting channel, that is a 9 channel. So need a NTC sensor. We are checking with the NTC sensor. Here I am using the NTC sensor. So for the AI1, whenever I connect the NTC sensor, in the 9th register I am getting the 28.2, 29, 27 something, that is the showing the temperature current. Okay, it's showing the current temperature. And do with the AI2, it is NTC2. So in mentioned register, that is a 10, I am getting the 27.9, that is a temperature. Do with the NTC3, I am getting the in 11th. NTC4, NTC5 and NTC6, NTC7 and NTC8. So on all the NTC I am getting the current temperature with the sensor. So here I am using the NTC sensor. Here we don't have any positive and negative, just we need to connect with the both wires, so we will get the NTC current temperature data. So this shows the all NTC channels are working properly.